Hey, so today I am going to be covering two-axis profiling cutting in RhinoCam for the CNC here at the Sam Fox shop. Let's jump right in. This is my Rhino file right here. I've got a shape that I'm going to cut out, and I'm going to draw, just for demonstration purposes, the stock box of the material that I'm going to be cutting it out of. It's a 2-foot by 2-foot piece of 1/2-inch plywood, and I'm going to be cutting this shape out of it. If you open up RhinoCam and it looks, or if you open up Rhino and RhinoCam doesn't pop up, it's going to look something like this. The first thing that I would check down here is to make sure that your units are in inches. If your units are not in inches, RhinoCam will not open when you open Rhino. So you're going to want to change that and make sure your model is scaled accordingly. If it is in inches and you don't see RhinoCam, you can pick it from this drop-down window right here and just click Mill. And if for some reason both of those things don't work, you can just type RhinoCam into the command browser or the command line, and it'll pop up the machining browser. Then we're going to click here to open up our tooling and make sure that we have all the tools here. These are the tools that are established in the CNC itself already. If you don't see these, you may need to click this plus icon to make sure they load. If you don't see anything at all, you may need to load the tool library from the desktop. So we're going to hover over this and say load tool library and click it. And you're going to want to find the most recent semester's tool library on the desktop. We do a good job of cleaning out the old tool library, so just clicking on that. It says 7 tools successfully loaded from the library. Perfect. I'm going to hit enter, and we're good to go. Let's start camming this. Let's come over here into RhinoCam and check out the left panel here. We're not going to click on 2 of the 3 of these, but we do want to click on post real quick just to check and make sure that our post processor is established correctly. We are going to look for this thing here to say Axes, which is the brand of our machine, ATC, which stands for Automatic Tool Changer, A2MC, which is the kind of controller that we have, so this is perfect, and then our posted file extension is .nc. Now we're going to sit here in the middle column for a second and establish what our stock material is. We need to tell RhinoCam what sort of material we are putting on the table, and we need to measure that material with a tape measure accurately before we input these measurements. It's very important that these measurements are accurate and true to what we're actually cutting. You're going to see immediately that RhinoCam creates this stock box for us based on the model that is in the program. So if your model is one of those models that has iterations that extend far out into any other plane, you're going to want to get rid of those. So if you do have a bunch of stuff that's way out here, just select what it is you want to cut, type the word invert, and then we're going to go ahead and type the word hide. That way those things are still in the file itself. We just can't see them, and nor can RhinoCam. So we're establishing the stock box. It should snap to the rectangle that I drew. If not, you can import 24 by 24 or whatever the material widths and lengths that you're cutting are. And then I know that my plywood is a 1/2 inch thick, so I'm going to put in 0.5. Hit OK. Perfect. And this is a good look at what my stock material looks like. However, my curves are not on the stock material, so I need to align those in the next icon down here. So I'm going to click Align and align the stock. You have the ability to align your art to the top or the bottom of the stock material. I'm going to align it to the top for now. That may be something that you change later. And I'm going to keep it in the center. If I didn't have this line around the outside here and I aligned my stock material, I'd have the opportunity to move this shape around to the different corners or edges of my stock material if I wanted to conserve materials. But I'm just going to pop it right down in the center. Cool. So now I need to align one more thing, and that is our absolute 0 point. Right here, it's sort of floating in space, and that's not where it belongs. It actually belongs right down here. So I'm going to click on the Align tab again, and then go to World CS, which stands for World Coordinate System. I'm going to set the World Coordinate System origin to the stock box, and I'm going to set the 0 face to the lowest Z and the 0 position to the southwest corner. This is one of the most critical moments in camming your piece to make sure that your world coordinate system is established appropriately. Otherwise, we may ruin some of our material. Perfect. So this looks good. Now that I have everything aligned and my stock dimensions established, I need to create a machining operation. Click on machining operations, and we are working in 2 axes, the X and Y axes. And I'm going to open this up, and you're going to be greeted with a bunch of really nice icons that do a pretty good job of describing what each tool machining operation does. And for now, we're going to stick to profiling. Once I click profiling, we're greeted with this window with a ton of tabs, and I actually click through each one of these tabs when I'm establishing a profiling operation to make sure that I know exactly what is happening and I'm telling the machine to do what I want it to do. So I'm going to click select curve and edge region, and I'm going to select my curve. And I'm going to hit enter, and it is selected. Now I'm going to click tool, and I got a couple of these tools that we talked about earlier that have been predefined. And I'm going to go with the 3/8 flat roughing end mill. And then on speeds and feeds, I want to go ahead and click load from tool. The speeds and feeds are a general good starting point for things that have a similar density to wood. If you're cutting MDF or masonite or foam, those speeds and feeds are going to be different. Clearance plane, that looks good. The clearance plane is the height that the tool moves to carry along the surface without cutting. And so its default is 1/4 inch over the material, which is why it's so critical that we put in the actual thickness and the Z height to make sure that our tool does not collide with the workpiece. And then cutting parameters. So if I were to start this job right now without establishing any cutting parameters, the tool would travel, the center of the tool would travel along the line itself, meaning that if we're using a 3/8 inch bit, we would have 3/16 being cut out on the inside and 3/16 of an inch of material cut out on the outside, and it would spin along the line like this. That's not what I want. I want to actually cut out the truly modeled size of this shape right now. So I'm going to click this box here that says use outside and inside of closed curves. And I'm going to use the outside of a closed curve, meaning that my tool is going to offset slightly so that the edge of the tool cuts along this line rather than the center of the tool. Now I'm going to come up here and click sorting. For this job, I'm not going to worry about any sorting, nor am I going to worry about any cornering parameters because I do not have any sharp internal or external corners to worry about. Advanced cutting parameters, a tab that needs to have some special attention paid to it. Our work holding, which is the way that our stock material sticks to the table, is a vacuum. And if you start to cut out little shapes from your piece, the vacuum will decrease on that small surface area, and those objects will lift up and potentially shoot across the room. So we need to keep those pieces attached to the greater workpiece as a whole. And I like to do that for every profile shape that I cut out, just to make sure that everything stays attached. Then I can slide my board off the table more easily and cut them out by hand afterwards, which means we're going to leave just these little tiny tabs that we can just knock off with a chisel. So we're going to come down here to bridges and tabs. I'm going to select some rectangular tabs, and I'm going to add, this is a pretty big shape, so I'm going to add 4 of them. Then we're going to come over here to entry and exit. For CNC milling wood, we don't need any sort of entry motions or exit motions, nor for foam or acrylic, or really much of what we're cutting on the CNC here. For a plasma cutter or a water jet, these would be different. But for the CNC router, I'm just going to select none. And then I'm going to come over here to cut levels. And this is the last thing we need to tell the machine is how deep to cut. We are going to tell the machine where our geometry is located on our stock box. And earlier, remember I set that to top, so I'm going to select at top. Then I'm going to select a cut depth, and my cut depth is going to be the thickness of my material, which is 0.5. And then I'm not going to worry about rough depth or finish depth. I'm just going to have my rough depth be the total of my cutting depth. And then we never want to cut greater than half the diameter of our tool down or over at any one point in time, meaning that if we're cutting a 1/2 inch with a 3/8 inch bit, we're going to need to cut 3/16 per pass all the way down the piece. If we try to cut all of this at once, we have the potential to break our bit or to ruin our stock material. So I'm going to set my rough depth per cut, and this is one of those instances where this backslash means per. So rough depth per cut is going to be set to 3/16 because that is half of my tooling diameter. If you don't know what 3/16 is in decimals, that's okay. You just put 3/16, and RhinoCam does the math for you. And then we're going to hit generate. You can see these lines here that are now on the outside of my curve and step down 3/16 each pass to cut out my shape. You're also going to see these tabs in here that are going to be used to hold the workpiece down and attach to my stock material. And this looks pretty good to me. Now, every time we create a profile or a cutting operation, we need to simulate it to make sure that everything is going to go all right and as expected. So I'm going to come up here to the right of program and hit simulate. And we are going to play this. And now you're going to see exactly what is going to happen when you start your job on the CNC. You can speed this up if you want to. And now if I come over the top of it, you can see the Rhino grid lines below, meaning we're cutting all the way through. You can see the tabs that are going to be left behind that are just providing some stability here. There's all 4 of them, pretty evenly spaced. And that looks good to me. The last thing that I check there's 3 things I check before I post a job, which is our word for export, and that is, does my object have tabs? And it does, we just saw that. I'm going to view it from the side and make sure that none of my cut lines extend below the 0 point on the Z axis, which is good here. And I also want to just double check and make sure my world coordinate system is set to the lowest Z. If you check these 3 things, your job is much more likely to succeed. So then when we're ready to post it, if you have a bunch of profiling operations in here, you can click on them one by one and export them. Or if you click Setup 1, highlight that, right-click on it and select Post. You can title it whatever you want. Up here, I'm saving this on my personal computer as to my desktop, but on the CNC machine, this should say Jobs. And then we're going to hit Post. It'll pop up with a bunch of G code, and this will automatically be sent to the CNC. And that pretty much does it for profile cutting on the CNC here at the Sam Fox School.